Welcome back. In today's video, we will be understanding about isotopes. By definition, isotope is atoms of same element having same atomic number but different mass number. That's isotope. Since they are atoms of same element, definitely they are having same number of protons in them. That's why atomic number is same. Examples of isotopes we can have, say for example, three isotopes of hydrogen are shown to us. That's 1H1, 1H2 and 1H3. One is called procium, second is called deuterium, and third one is called tritium. Carbon has three isotopes, carbon 612, 613 and 614. Say for example, chlorine 1735, chlorine 1737, these are two isotopes. Now one more thing about isotopes is that different isotopes exist in different percentage in this universe. That percentage of isotope in which it exists in this universe is called percentage abundance. Most of the elements occur in different percentage abundance of their isotopic forms. Therefore, atomic mass of element is the average mass, and that is the average isotopic mass basically of all of its naturally occurring isotopes. Say for example, if an element doesn't have any isotope, that means there is no average isotopic mass in that case. And the mass of that element will be just the sum of the masses of protons and neutrons present in its nucleus. There is no isotopic mass in such case. Let's understand this percentage abundance in with a quick example. Say for example, we have chlorine 17 and 35. Another isotope is chlorine 17 and so it's chlorine, sorry, 37. Okay. Now this isotope, which is having atomic mass of 35, it constitutes 75% of total chlorine present in this universe. 75% of total chlorine atoms present in this universe. Now, out of 100, 75% is in the form of chlorine 1735. Now, rest is 25%, that's in the form of chlorine 1737. So, remaining 25% out of 100 is in the form of chlorine having atomic mass 37. Now, this percentage is percentage abundance. So that is what is written over here. Percentage abundance is occurrence of an isotope of an element in nature. This is what we have learned about it. 75% of chlorine is in the form of chlorine 35 and 25% is in the form of chlorine 37. Now isotopic mass, that's an average isotopic mass, can be calculated by using the formula M1P1 plus M2P2 plus MnPn. What's small m? Small m is the given mass of an isotope. What's P? P is percentage abundance. Clear? Let's try to calculate average atomic mass of chlorine. You know that if you look into the periodic table, you will see that the mass given for chlorine is 35.5. Neither it is 35 nor it is 37. It's 35.5. How that mass has been calculated? That mass has been calculated by using this formula. We are also going to use that. Say for example, average mass of chlorine atom will be calculated as mass of first isotope, that is 35, multiplied by with its percentage abundance, that is 75%, plus mass of second isotope, that is 37, multiplied with its percentage abundance, that is 25 by 100, that's 25%. Solve this, it will come out to be 35.5 grams. if you are using 35 grams and 37 grams. If you are using 35 units or atomic mass units, then the end result will be also in the same unit, AU, AMU. Okay, great. Now let's move ahead and understand about different properties of isotopes. This is for your understanding, this diagram. It constitutes 75% of the circle is covered with 1735 isotope and rest 25% is as 1737. Properties of isotopes. Isotopes have same chemical properties. Chemical properties are same. Same chemical reactions will be shown by the isotopes. Why? Because their atomic number is same, their number of protons is same, their number of electrons is same. So that's why chemical properties are identical. But physical properties vary. Physical properties are decided by mass, atomic mass. That is collectively number of protons and neutrons present in the nucleus. That's number of nucleons. Third point is, higher the mass of an isotope, higher will be its boiling point. That's very important. You will be tested for that. If we take example of hydrogen 1H1, 1H2, 1H3. So here is the higher mass, its boiling point will be higher. Higher boiling point. If you are asked in your examination that arrange three different isotopes of hydrogen in increasing boiling point or decreasing boiling point, so you must not get confused about the question. It's from here. Higher the mass of an isotope, higher will be its boiling point. Okay, so that means 1H1 is having least boiling point, then 1H2 is having less boiling point than 1H3. Okay, so this is the order, boiling point order, increasing order. One more important point about isotopes is isotopes with extra neutrons in their nucleus show property called radioactivity. Radioactivity is spontaneous emission of radiations. Whenever an element is spontaneously emitting radiations in the form of particles, okay, alpha particle, beta particle, gamma rays, and all that, we say such elements are radioactive elements. And this radioactivity arises right within the nucleus of an atom, first of all. Why? Because number of neutrons are getting more. So if there is more number of neutrons than the protons, then the element will be radioactive. Say for example, in case of 1H1, 1H2, and 1H3, if we try to figure out number of neutrons, so this is also very important. I have shown you a method in previous videos how to calculate number of neutrons. That is when we discussed atoms or symbols of atoms. Number of neutrons is mass number minus atomic number. For first one, mass number is 1, atomic number is 1, so number of neutrons 0, no neutrons here in first case, in case of 1H1. In case of 1H2, it is 2 neutrons minus 1 proton, that is 1. Okay, so there is 1 neutron in it. So 1 proton, 1 neutron, no radioactivity, because number of neutrons and protons are exactly same. In the third one, it is mass number is 3, atomic number is 1, so 2. 2 neutrons are there in this nucleus and 1 proton. So clearly number of neutrons are more, extra neutrons are there present in this nucleus. So this is radioactive. Tritium is radioactive. Moving ahead, we have uses of isotopes. So isotopes have a very great use in the field of medicine. First of all, cobalt 2760 is used in the treatment of cancer. Radiotherapy is one of the method of treating cancer. In that radiotherapy, the isotope which is radioisotope is 2760 cobalt. Then carbon isotope, that is carbon 614, is used to determine age of fossils. Okay, so this is called radio dating. Radio dating or carbon dating. Carbon dating. My question to you is that why only this isotope, that is carbon 614, is used in radio dating? Why not 612? Why not 613? Why only 614? That's my question to you. Please drop your answers. Another isotope is uranium 92 235 in the comment section. Fuel in nuclear reactors, nuclear fission and fusion, all that. And isotope of iodine 53 is atomic number, 131 is mass number. It's used in treatment of goiter. Goiter is what? Goiter is enlargement of thyroid gland, and that's goiter. So in order to treat that goiter, iodine isotope, that's 53 131, is used to treat this. So we are at the end of the session. Please subscribe to my channel. I hope you have understood the topic. If you have any question, please drop that in the comment section, and do subscribe to this channel, please. And press the bell icon as well, so you don't miss any update from my end.